All right, 3.4 part 2, the second derivative test. Remember what we're testing for with the first derivative test is testing critical numbers to see if they're maxima or minima. The second derivative test is another test you can use to test your critical numbers to see if they're maxima or minima. It's using the second derivative. So the second derivative test uses the idea of concavity to determine which critical numbers. Sorry about that. The second derivative test uses the idea of concavity to determine which critical numbers are extrema. So if a critical number is in an interval that is concave up, what do you think that critical number is, a maximum or a minimum? So think about a concave up portion of a graph. There would be a critical number right here. Obviously that would be a minimum, right? So C is a minimum. If a critical number is in an interval that's concave down, that critical number would be here, so that C would be a maximum. To find C, we still have to set the first derivative equal to 0, or think about where the first derivative is undefined. We still have to do that to find C, or to find the possible maximums or minimums. But then we can take our second derivative and plug C into it and talk about concavity. So if before we do that, if the second derivative is positive when we plug in our critical number, that tells us that the function itself is concave up. Uh-oh, that looks like a swear word, huh? Then C is a minimum. All right, then C is a minimum. So if your second derivative is positive when you plug in your critical number, then your C, that critical number, is a minimum. So it's kind of opposite of our intuition. Remember that second derivative stands for concavity, so our graph is concave up and C is a minimum. If our second derivative is negative, that means our graph is concave down, so that C is a maximum. So if your second derivative is negative, C is a maximum there. And there will be times when the second derivative actually equals 0. So it's not concave up or concave down there. The graph is not concave up or concave down there because your second derivative equals 0. You can't tell anything about C, so that means that the second derivative test fails. And you have to go back and do the first derivative test. Remember, the first derivative test and the second derivative test are all testing critical numbers to see if they are maxima or minima. So, sorry about all the interruptions here. Find the relative extrema using the second derivative test. So first we find the critical numbers using the first derivative. So we've got negative 15x to the fourth plus 15x to the second. We set that equal to 0. So we pull out a negative 15x squared, which leaves me with an x squared here, minus 1. We can factor that again to x plus 1 times x minus 1, or we could just solve that by itself if we want. So set each factor equal to 0. If we set negative 15x squared equal to 0, we can have that, and x plus 1 equals 0, and x minus 1 equals 0. So x equals, divide by negative 15, take the square root. We got 0 for one of our critical numbers. Subtract 1, so another critical number is negative 1, and add 1. So we have 3 critical numbers. 3 places where our first derivative equals 0. Now we're going to plug those critical numbers into the second derivative. So we need our second derivative. Taking the derivative of the derivative, negative 60x to the third plus 30x. Now we don't want to set that equal to 0 because I don't care about points of inflection. I'm going to take that second derivative and plug my critical numbers in. So I'll plug in negative 1, and I'll plug in 0, and I'll plug in 1. So when I plug negative 1 into my second derivative, a negative 1 cubed is a negative 1. And then negative 60 times negative 1 is positive 60. And then 30 times negative 1 is negative 30. So I have 60 minus 30, which is 30. I don't really care about the number. All I care about is if it's positive or not. So if my second derivative is positive, just thinking about my function, it means my function is concave up. So if the second derivative is positive, the function's concave up, so my critical number is a minimum. So this step in here you don't have to have, it's just me thinking, that's how I think about it. Putting a 0 into the second derivative, 0 here, we get 0. So the test fails for 0. So it doesn't tell me if 0 is a max or a min. I'll have to do the first derivative test on that. But I can use it for the 1. Put 1 in, you get negative 60 plus 30, which is negative 30. Again, I don't care that it's what number it is, just that it's negative. If my second derivative is negative, thinking through, my function's going to be concave down, so I'm going to be having a max at 1. All right, so since, going back to this critical number of 0, since the test failed, I do have to set up my intervals. So negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. I already know that 1 is a max, and I know that negative 1 is a min. I just have to figure out what's going on at 0. So all I have to do is look at the first derivative for these two intervals. Pick a number. Oofda, a lot of interruptions, sorry. Pick a number between negative 1 and 0, like negative 1/2. If I put negative 1/2, where am I putting it? Into the first derivative, because I'm doing a first derivative test. So put a negative 1, I'm going to put it in here. This is the best form to find signs. Negative 1/2 here squared would be positive times a negative number, so that part's going to be negative. A negative 1/2 here is going to be a positive number, and a negative 1/2 here is going to be a negative. So I have a negative times a positive times a negative, which will give me a positive. So my first derivative is positive, so my function is increasing, and at 0 to 1, I plug in a 1/2 into my first derivative. Keep track of which test you're using so you know which things you're plugging it into. Go to here, 1/2. 1/2 squared is still 1/2. A negative 15 times that will be a negative number. A 1/2 here will be a positive number. A 1/2 in here will be a negative. So I have a negative times a positive times a negative. That gives me a positive. So if my first derivative is positive, my function is still increasing. So if my function's increasing and then it keeps increasing, the derivative sign did not change. So 0 is neither a max or a min. It's nothing. So the only thing I have here is negative 1, whatever, is a min, and positive 1, whatever, is a max. So let's find those whatevers. Put negative 1 in here, I get 3 minus 5 is negative 2. Put a positive 1 in here, I get negative 3 plus 5 is positive 2. So those are my min and my max. 0 is just a point on the graph where maybe it changes concavity or something weird happens, but it's not a min or a max because it increases and increases. Increases on both sides of 0. Okay, again, if you want to find where something's concave up or down, just to review, we have to take the derivative. So this is low d high minus high d low all over low squared. So I have 2x cubed minus 8x minus 2x cubed plus 2x all over x squared minus 4 squared. So that's going to be 2x cubed minus 8x minus 2x cubed minus 2x over x squared minus 4 squared. Combining like terms, my first derivative equals negative 10x over x squared minus 4 squared. Now I need the second derivative. So second derivative equals low d high minus high d low. I've got to do a chain rule on this part to do the derivative of the bottom. So that's what I get when I do my chain rule. And then x squared minus 4 squared squared is going to be to the 4th power. A lot of simplifying needs to happen here. So right now I'll just factor this, multiply this out. X to the 4th minus 8x squared plus 16. And here I think I'll multiply the 2x and the 2 and the negative 10x. So that's going to be plus 40 x squared, and then times x squared minus 4, all over x squared minus 4 squared, to the fourth I mean. So negative 10x to the fourth plus 80 x squared minus 160 plus 40x to the fourth minus 160 x squared. Combining like terms still, I'll have 30x to the fourth minus 80x squared minus 160 over x squared minus 4 to the fourth. All right, I'm going to factor the top, so I'm going to divide out the greatest common factor, which is 10. So I'll have 3x to the fourth minus 8x squared minus 16. And that's going to factor to 3x squared times x squared. And then to get the 16, I'll have a 4 times a 4. I want a negative 12 and a positive 4 to give me my negative x squared, and negative 8x squared. All right, so a lot of simplifying. That is the second derivative. So I want to set that equal to 0. Where the top equals 0, well, this will never equal 0, because something squared will always be positive. I'll write it out for you. 3x squared plus 4 equals 0. If you subtract 4, you'll have 3x squared equals a negative number. Dividing by 3, you can't ever have x squared equal to a negative number. That could never happen. So that doesn't help us at all. We can set this equal to 0. Add 4 to both sides. Take the square root. We get positive and negative 2. So we have possible points of inflection. So we have possible points of inflection at positive 2 and negative 2. And also we have to think about what makes the denominator equal 0. But that's going to be the same thing. We actually could have canceled that. I didn't see that. So the denominator equals 0 at positive and negative 2. So that's where our second derivative is undefined. So we have these two possible points of inflection. So we have, to set up intervals, negative infinity to negative 2, negative 2 to 2, and 2 to infinity. And we are checking values, because we're looking for concavity, we're checking values in the second derivative, so in here. So if I put a negative 3 into my second derivative, that's going to be positive, positive, positive everywhere on the top, and positive, so everywhere positive. So the graph is concave up here. And then f prime, if I put in a 0, I get positive on the top and a negative on the bottom. So my graph is concave down here. Oops, sorry. And then putting like a 3 into the second derivative, positive on top, positive on the bottom. So if my second derivative is positive, then my function is concave up. So does the concavity change at negative 2 and 2? Yes, it does. What intervals am I concave up? It's concave up from negative infinity to negative 2 and 2 to infinity, and it's concave down from negative 2 to 2. There's your homework.